Okay, so we'll talk about strings and characters, and then we'll talk about vectors, right, which are lists in C++. So a character, as we've known, we've not talked a lot about characters, and all we know right now is that we can create a data type character and we assign it a character, and it has to be with single quotes, right? So beginning and ending single quotes. And not yet. And then a string, assuming that I have the correct include statement and namespace qualifier, double quote, and ending double quote. And that's how we create them. If we go there shouldn't be a conflict with string, so I don't know if the configuration was incorrect, but let me see, we'll see about that. So let me close this, close folder, and this class is this one. Close all. Looks like I have someone checked static variables and overloaded functions. Oh, I typed too much. Let me see. Okay, so let me check this in. So I stage them, commit them. Let me do a pull, just to make sure there's something in the cloud for me. I can bring it down, and then I can do a push. Okay, so we come here and we'll work for ranged. We'll do some examples here, right? So we'll do for range. So it's a special kind of loop. There was one in Python, so we'll get into it after we talk about strings, right? So we have a string include here. Once we have the include, we can say stat string name equals John. And then we can say that we want to create a character with the letter. Okay, so if we say name and then period, notice that it gives us some functions that we can use to ask the string some questions or to modify the string. So like we can ask it like, how long is the sequence of characters that you are storing right now? Or we can say that we want to append to the sequence of characters that it's currently holding, right? So how can that be, right? So if we do the same for letter, then letter doesn't have any functionality. So if we go back to our diagram, so then the character is fundamental types, they call them, or simple data type. And then the string, someone wrote code in a class, and hopefully you were introduced to classes in Python, right? So a class in its simplest terms is a way that we can use variables and functions to describe some object or to give life to some object, in this case a string, right? So when we create a variable and it's in memory, so if it's in memory, so if a class is in memory, then usually they refer to those as an object, right? But string, class, so someone wrote some code like to allow us to ask it some questions, right? So size, and I should have given myself some more space. Let me delete this. So there's some data type. So we know there's a character sequence. We won't get into the syntax of how they create that yet. We will later on in the semester. And then they use some special integer, I'll talk about that in a little bit, to allow us to ask it, hey, what size is the sequence of characters that you're holding? And then they wrote code for that. And then they also wrote code that allows us to append. And I think they used again a character sequence data type. We won't get into that. And then they wrote the code for that. So this is in a data structure known as a class, and that's how the string's created. Now the character is not a class, right? It's just a simple data type that has no functionality. So the name is like, it can describe itself, it can append to itself, and the letter is char type, so it's kind of like a very simple data type, right? It doesn't know anything about itself. Questions here? No questions? Everything's clear so far? Okay, so at least we know, right, that a string is encapsulated, or the details of how it works are hidden away in a block known as class, and the letter is just a simple old data type. Okay, we create another page here. And then we can go ahead and describe how these two data types would look in memory. So we have char, letter, A, and then string, again, assuming I have the correct configuration, includes and everything, this code would work. Name equals John. Again, please remember, char single quotes, string double quotes. Okay, it's not like Python where strings you could use single or double quote. In C++, they're differentiated, so please keep that in mind. Okay, sequential, and this guy on the right side, we've not really used it yet, but we will today. So when this statement, assuming this would be our main program, executes, then letter would be at some address ending in 4, the value would be A in binary, right? We'd have to look up the ASCII value of A, and that's what we will see there in binary. And it's only 1 byte, meaning the next address would be 5. Unlike numbers, when we jump by 4s, because numbers are stored in 4 bytes of memory. So questions here? This one we should be comfortable with already. Okay, no questions. So how is a string stored in memory? So recall, well, you probably don't recall, but I'll help you remember. When we were talking about, or I was talking about the stack and the heap, I was saying that for the most part, C++ manages the stack memory. And then I said that heap is managed by C++, or it can also be managed by a developer. When we use a string, C++ manages the heap. Like some other developer wrote the code, but we, like the one who's currently using this program, does not have to worry about allocating memory on the heap. When I say string name equals John, something happens to the stack and then something happens on the heap, and that's what we will I will describe, right? And hopefully I can describe it in a way that makes sense. So when name equals John executes, it'll get the next available address, some large number 5, and then we'll get some memory on the heap. I have to hold the monitor. X 22, X 23. So it's random, so it can pick any address. But what goes on the right side and what goes on the left side is the question, right? So the book kind of talks about it, right? But it doesn't like give you like the whole picture of what's going on. The book just shows you like address cells, but I try to like give you an overview, like a bigger picture, a better picture of what's happening in memory. So this one's gonna have some value. And then say it picks 20, J is going to go there, O is going to go there, H is there, N is there. Again, their binary value of the ASCII value for J, O, H, and N. What goes in Y5? What do y'all think would go in Y5? Yes, the stack will hold a memory address. So I know we talked about references, which allow us to store addresses, but this string is using like a cousin of the reference, which is a pointer, but we won't talk about pointers till later on in the semester because that's a difficult concept, right? So I always like leave it toward like the 10th or 11th week. The heap memory address. But which one? 20, 21, 22, or 23? Y5, John, those are letters, X20. So Tabitha, yeah, so we no longer have to worry about what's here. It'll store like some large address X20, and then we draw an arrow to show that it's pointing to that region of memory on the heap. So if we go back to this diagram, here, not only are they allowing us to query it for size and append, they wrote, the creators of this string class, they wrote some code that creates memory. When this statement executes, name equals John, the heap allocates a chunk of memory, and then it makes it available. So when we say equals John, then the memory that's given, or that the developer dynamically allocated on the heap, JOHN is stored at each address. And again, it's jumping by 1 because we only need 1 byte for each letter, right? 1 byte of memory. So, questions here? Yeah, so there's some complicated code in the string. So Adrian's asking, like, well, how many, like, it stores addresses and then how many after that it uses, right? So assume that there's like some counter. So maybe it's like, okay, give me a chunk of 15 addresses. So then there's a counter. So that it's 0, 1, 2, 3, 4. So the next append that we do will be stored at address at index 4, right? So meaning like 0, 1, 2, 3, 4. So it will be stored here, right? So, and once it gets to the limit of the fifth, or like to 14, right, which is the max, and then say like John's last name is, or maybe we store like John Smith Jackson, I don't know, like some long name. So then we don't really have space anymore with 15 characters. So then the developers of the string class have code to account for this. So once the original chunk of memory is exhausted, then they have to allocate new memory, which can fit the long name for John. So they get the memory, they copy the values to the new memory, and then they delete this memory, right? So that we're not grabbing memory and not releasing it, because although the heap is large, it's not infinite, right? So if we just keep on grabbing memory, our program will eventually crash because we will exhaust the memory that's been given to the program by the operating system. So those topics, believe it or not, like those concepts, or that what I just described, we will code that ourselves later on in the semester so that we can get very good at creating dynamic memory, using it and releasing it, and always making sure that we do that so that we don't create memory leaks. So other questions here? So make sure that you understand that the values of a string variable are stored on the heap, and a reference to those values is stored on the stack. What is a reference? An address, right? So an address will be x20. That way we know, oh, okay, x20. So it points to the first item in the array, and then from there, there's code written that allows the string to know that, yeah, I mean, that's where my values are. Well, the heap gives us a chunk of memory, and then the sequence of characters have to be stored sequential. So we say they gave us from, and this is hypothetically, I mean, I don't know exactly, like, so say they gave us addresses x20 to x34, then we have to use these addresses sequentially. Like, we can't have, say this is 20 and this is 30 and 34. We can't have like J here and O here an H here, and then N here, right? They have to be stored sequentially. So please make sure that you understand that. What's random is the chunk of memory. Like if we run this program again, maybe we don't get 20, maybe we get like 10 or 100 or whatever, right? So okay, so any other questions? You will definitely see this diagram and questions about this diagram in next week's quiz. So please make sure that take a snapshot, take a screenshot, whatever, right? And write notes so that you understand what's going on here. Okay, so that's kind of like the theory and the technical portion of string. So now we can go and actually create a string. So we don't want to mess around with a character anymore for now. So I'll go ahead and say using string and using cout. That allows me to do this, right? So I don't have to. So this is one way to create a string. Name equals John. I can also say name1 like this. So this right here, if we go back and look at our diagram for the class, they write some special code known as a constructor. So then again, this is a char sequence function parameter, and there's code in this special function that initializes the string. So that's why we can call that special function known as a constructor to do this, to initialize this, create and initialize a string. And then we can also say let me see. Well, first let's create another string. String, well, maybe John Doe, right? So John Doe, and then we say, okay, let me create another string from the name variable, and let me make sure I get this correct. So we want to start at index 0, 1, 2. We'll start here at 2, and then we'll move 1, 2, 3, 4 characters. So it should give us HN space D, and we'll check that out with the cout in a little bit. We can also just like this one, maybe let's do that. Copy constructor. Again, the constructor is what I described here. It's like they wrote some no feedback. They wrote some special code, name of the class, and then character sequence. They write some code there to initialize the string. So that's why this constructor copy, it should be the opposite, right, is copied into this character sequence variable that lives in the class. And that code is in this function. Okay, and we can also create another variable, and we can say too long, I am too long for the buffer. So we can also say like, hey, create a string, but only allocate, let's see, 1, 2, 3, 4, 5, 6, 7, 8, let's say 8. So only save 8 spaces for me. So then we should only see, when we see out, we should only see I am too long, because we purposely created a sequence of characters that's longer then what we said we were going to provide, just to show you that they wrote code like to make sure that if we say we want a buffer of 8 characters and we give more than 8 characters, it's just going to truncate the piece that's too long. And then we can also, the book doesn't really talk much about strings. It just kind of tells you, yeah, strings are there, and it shows you like a few functions, but it really doesn't talk too much about them. But strings are used like extensively in the industry, so that's why I at least like to give students one lecture of strings and vectors. And again, it also doesn't talk much about vectors. It just kind of tells you this is a vector and this is how you use it, and then that's it. So we can say create 10 x's, right? So we create a string of length of 10 with all of them x's. And then there's other ways, but we don't get into that because those are advanced topics. So then we can say, well, let's see what we did here. So we'll say see out the first one, name 1, name 2, name 3, name 4, name 5. And then we can go ahead and execute this program. Source. And then we go to 4, and we are in the 4 range. Then we come here and let's run it. So we were wondering what this was, right? So let me see here. What does it say here? Partial specialization. So this right here outputs a 1. Let me see if it was what we thought it was. So we thought it was this, but I don't think it is. But let's see. I want to see what's displayed if we try to display that special sequence. Nothing, right? So that's homework for me because we didn't know why it was outputting a 1. We're thinking that 1 was maybe for the empty string, but that doesn't make sense. So I still have to find out why. You see, it's displaying a 1 for name 1. Okay, so let's go through this. This one's simple, right? So John Doe. This one, we're still wondering why it outputs a 1. Here we said create a variable for string name 2 from existing variable name 2, start at 2, and then give me 4 characters. So we said 0, 1, 2 at H, and then 4 characters, 1, 2, 3, 4. So then it displays HN space D. And then we can just use the special copy constructor for the sequence of characters, this one, and it outputs that. And then let me see here, 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So actually, let me see, I think it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it displays IM2, right? Because we said from this sequence of characters, give me a buffer of 8, or in layman's term, only store 8 characters. So that's why it ignores from here all the way to the end. It truncates it, it just ignores it. And then the last one is create a string 10 characters long and make all of them X's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any questions? And this is different ways. We have one, 1, 2, 3, 4, 5, 6 different ways that we can initialize a string. So we create or we declare a variable and then we assign it some value. That's what we're doing. So no questions yet. Okay, so if we come back to the diagram, so we see that it has addresses, so J-O-H-N, although we have John Doe, right? But we can access one character. So we can say cout name, and if we want to display the letter H, indexes start at 0, so 0, 1, 2. So we'd say 2. Right, so we go back and look at the diagram, assuming we want this one, so this is index 0, 1, 2. It has nothing to do with the addresses. Although we can assume that the compiler knows that if it's 0, then it's the first address. And then if we say 1, then it's the address plus 1, right? So there's some compiler magic going on there. And then we can run this program again. Right, so right here, H. And since John Doe is a name, we can also modify a character using the subscript operator, meaning the open close parentheses like we do here. So we can say 0 is not lowercase j, but it is uppercase j. And then it's D, so we go 0, 1, 2, 3, 4, 5. So we can say name at 5 equals capital D. And then we can output again and run it. Run in terminal. You can do the last date with substring, but you can Google that, and that's for Irving. Yeah, just type a C++ string substring, and you can do that. So notice that we were able to modify J and D from lower to uppercase. Questions so far? I mean, Irvin's asking if we can take the last state. Yes, using the substring operator. I mean, function. Okay, no questions. Okay, so what else? Iterating through a string, right? So we are in this for-ranged example. So for-ranged, I don't know what it's called in Python, but you can iterate a list and you can say like for item I in items, and then each time you iterate, it gives you the current element, and then it iterates, it goes to the next element, until finally it goes through all the elements. We can do that here with the for-range loop, but before that we can also iterate a string using subscript operators, using either a for or a while loop, and maybe the for is easier because we can use the header. We can say integer I equals 0, I less than name dot size, and then we increment I. So we can say cout the current character and then display a new line, and then we put new line over here. So that's how we can iterate a string using a for. And notice we use a string function that gives us the size of name, and then we loop why less than, because John Doe is how long? 1, 2, 3, 4, 5, 6, 7, 8. but the index started at 0, so we would go 0, 1, 2, 3, 4, 5, 6, 7. And if we do 8, we go beyond the memory region that's string saving, and then we'll get a memory error, right? So let's go ahead and run this. Running terminal. You are just going through and replacing based on the position within the string. No, it's a sequence of characters. So it's a sequence of characters, right? So that's why we have to do it like this. And that's why over here I was talking about characters, and then the string is a sequence of characters. Yes. We'll talk about vectors in a little bit. Okay, so where was I? So we loop through it, and so JOHN space DOE, right? So this loop, but notice here we're getting a warning. And well, that warning really doesn't make sense, not even to me, right? But I know what the warning is. If we look at the size function at the top right here, notice that the return type is some special or some size underscore t, stud size underscore t. So we're like, oh, well, what's that guy? So we can go size underscore t, and then see if it gives us some. Let me see. Okay, right there. That's all. So notice at the very top right here, there's a special keyword type def, and then it's using a data type, unsigned integer. Unsigned integer, what does that mean? It means that it's only going to support positive numbers, so then it can hold a value twice as large as an integer, right? Because integers can hold negative and positives, but an unsigned integer only holds positives. So the warning is telling us that we may get an buffer overflow. Like it may come to the point that the size of the name variable is too big for an integer, and then our program is going to perform weird. So what we want to do instead is we want to use this special data type instead of int. So we say size underscore t. That's the same thing as saying unsigned int some variable, right? But we'll go with this, and then I will run this in the terminal. And now my warning's gone, which is good, right? So anytime in this class and in the industry or wherever you are and you're using C++ and you want to iterate a string and you want to use an index or a subscript operator, then make sure you use this, right? Because you don't want your program to be producing weird results later on when you're gone, or when you're supporting it and you're like, well, it looks right to me, right? So this is important. Questions so far? Okay, so we can also say for, and I'm saying that a string is a sequence of characters, and that there's some character variable in the class. So let's test that theory. So then I should be able to say for each character in the name string, the string name variable, then each loop, the first time it'll give me access to J, second time to O, third time to H, and so forth and so forth. So I should be able to do this. See out each character in a new line, right? So then let me create a new line here. And maybe I can put here for ranged. That way it's clear. Okay, and then we go ahead and execute this, run in terminal. So above the for range, this is the for loop, and then this is the for range loop. It's easier syntax, right? Like we don't have to worry about the size or anything. We just say for each character C in name, do something. There are times where we may not know like how to deduce the data type. So if we just stick to the magic auto keyword, then that'll take care of letting us know what C is. And we can check that by just hovering over C, and then it'll say, oh, C is a chart type. And then we should still be able to run this in the terminal. So if you remember that syntax, it can save you a lot of time, right? So JOHN, right? So it still runs. And then now this is like we're just letting the compiler do the thinking for us. Questions so far? Okay, no questions. So I think for now we'll cover strings and vectors using functions in the next class, but for now this is all I wanted to talk about as far as strings is concerned. So now we go and we talk about vectors, and just like strings, a vector is part of the C++ standard library, and meaning if we want to use it, we have to include something, and that'll be the vector header, and then we have to help the compiler narrow down the scope or tell it where to find the vector, and we say you can find the vector in this namespace. Once we do that, then we can use the vector. Okay, so like the string, which is it's a list of characters, but a vector is more powerful. A vector is can be a list of objects, a list of something. It's not just characters. It can be a list of integers. It can be a list of doubles, a list of bulls, a list of chars, a list of strings, a list of user-defined types or classes that we create. So vector is very powerful. The only thing is that the syntax sometimes, like to create the vector, sometimes students are like, what? But once you get through that, then it should be okay. So a vector in memory is just like the string. So assuming I have the correct configuration to use a vector, I can say vector, and then less than, say I want to create a list of integers. I name it nums, and then I can initialize it with some values. So that creates a list of 3 elements, the values 10, 3, and 2. In memory, it'll work just like the string, but again, the string can only work with characters, but a vector can work with different data types. So that'll hold a reference there, and then we have some addresses. And with numbers, the addresses are in 4 bytes. So we have to keep that in mind, right? So if this was x4, then this is x8, x12, x16, 20. So say it picked 12, 16, and 20, right? That's the chunk of memory it gives us. So then we can say, let me use blue. The values 10, 3, and 2 are here. And again, we should know by now that x12, the address of 10 would go here. And then we... No, okay, sorry. Yeah, so do I have to repeat something? Did I cut out? Sure. Okay, everything? Okay, when I'm allocating them in memory? Okay, so I added these addresses, right? They are in multiples of 4 because integers are stored in 4 bytes. And assuming this is the first statement in main, then we would get some address. I always pick 4. We can pick any address, right? So then 10, 3, 2, we get a region of memory allocated to by the vector. And then we say 10, 3, 2. So then that's why we have 10, 3, 2 at addresses 12, 16, and 20. And on the stack, y4, the variable nums, points to address x12 so that it can go find the values or the list for the vector. And that's how this works. And as, say, the vector may allocate only 3 address spaces initially when we run the statement. Maybe there's 3, and if we add another one, then it'll duplicate or double the memory, so then we would have 6, right? But how can we check that? Well, we can, so the vector, just like the string, is a class, so we can query it. We can ask it questions like, hey, how many elements do you have? What's your capacity? Like, how many elements can you store currently? Stuff like that. So let's go and, well, before I move on, any questions here? Okay, so far no questions. So we go and let's write some code, right? So this was for strings, and then we got vectors here. So we can jump here, and then we can, I said it's from the standard library, and we need to include the vector header. So that one's easy, include vector header using stud vector. And now we can simply say vector of integers, name nums, create a list of these elements. So let's go ahead and include IOStream also. And then we say using stud cout. And now we can display the screen. Okay, so we have a cout capacity, so like how many elements can you store, and let's see what it returns. Okay, so cmake example 0406 run in terminal. So 3, okay. How can I add an element to the list? So let me see, nums dot capacity, begin, clear, data, in place, empty, front. Let's use this one, pushback. That's the most common one that we use, right? So what's pushback? It will add a vector at the last address, okay? So then let's go ahead and see what happens if we do pushback and then we add the value 20. I want to make sure that I do capacity before and after. So let's see what happens. Run in terminal. So originally capacity is 3. Let's go back to our diagram. So it seems, right, without looking at how they wrote the code for the vector, that it only allocates enough spots for the list, which makes sense, right? Because they want to use memory efficiently. I mean, there's no sense in behind the vector is an array, right? So it's an array of objects. Like in this case, it's an array of integers. So if we do the same exercise that we did for so somebody wrote code in a class structure for the vector, and there is a special data type dynamic array of something, of objects, right? In this case, it's integer, so dynamic array of integer. And then there's some special code written by the developers that allow us to use this kind of array, right? So we can just say, like, hey, from this list, create a vector. So they wrote some special code for us. We won't get into the details, but yes, there's an array behind the scenes, but we don't have to worry about creating memory for the array, and the array doesn't have enough memory anymore. We need more memory. What do? We need more memory. So get more memory, copy the values from the current array to the new memory, delete the original memory so that we're not leaking memory. So all that is taken care of for us. And all that was also taken care of for you in Python. I don't know if the professor got into details about what goes on behind the scenes, but the list and the string that Python uses the same concepts, but they use the Python language. Okay, so I was saying here it allocated only 3 slots. So then once we added another element, all of a sudden it has 6 slots. So what probably happened is we got a chunk of new memory of 6 slots. So then this 10, 3, and 2 values were copied to a new memory. And once the copy was complete, then this region of memory is no longer needed. So it's deleted, and then this x12 will maybe be pointing to like maybe x30 or something, to the new region of memory. All these concepts that I'm introducing right now, we will actually code them toward the end of the semester so that you all can get a good experience in like how to create objects and classes that manage memory. Right? They're difficult concepts, so that's why I always leave them toward the end of the semester. Okay, so questions here? Again, this is important. Like for now, don't worry about like what happens with memory copying. Just make sure that you understand that the data lives on the heap, and the stack has an address that points to where that data is on the heap. And that should be good enough for now. Okay, so we come here. So as I was saying, right, capacity was 3, and then 6 right after we do a pushback. So how do we access the elements? We can use Subscript Operator. That means open close parentheses. So we can say nums at 0, 1, 2, 3. So let's make sure that 3 is 20. So we can say this. Run it again. That should display 20 for us. All right. 20. Why 3? So let's go back over here. So we, assuming this was a new memory, right? So we added 20 here. So it'd be index 0, 1, 2, 3. And that's why it displays 20 right here for us. And like the string, we can also have it what is the 3 increase in capacity? That means that originally it only had 3 memory slots, and then we added 1 entry. It didn't have enough memory allocated, so it had to create new memory. Is a character 2, character 0, and then character I'm not sure I understand your second question. You mean integers? No, the integers are stored. There's no special terminator or anything like that. No, they're elements. It's just an integer, right? So we say we are going to create a list of integers. So I keep my promise and I give it 3 integers here. And then I'm like, okay, I want to add another integer to you. So I add it, and I was saying we originally only have 3 blocks of memory. That's not enough memory. So when we say push back 20, then new memory is allocated to us. So let's say 24, 28, 32. Let's say it gave us 32, 34, and 44, right? Let's say it gave us those. So then 10, 3, and 2 are copied. So 10, 3, and 2, and then 20 here. It deletes that memory, deletes that address, and then this one would hold x32, and then it would be pointing to the new memory. Can you all hear me? Everyone's having issues? That's Buddy, hold on. Mm-hmm. Okay, can you all hear me? You might hear the fan because I can't connect my Bluetooth. But can you all hear me? Yeah. Yeah, I don't know what happened to the Bluetooth. But I mean, we're almost done here, so I won't worry about plugging it in for now. So let me see, I come back here. So everyone understands this? Like, we'll talk more about this later when we actually code it. Like what happens when all that happened after we said push back 20, right? There was not enough memory. No, it's integers. Like if we say integers, then it's numbers, right? So we are saying here, create a list of numbers. It's not a string for numbers, it's a list for numbers. And it doesn't just have to be numbers. It could be any other data type. It could be doubles, characters, strings, or our own user-defined types. Yeah, okay, and we can also, so I said that we could access subscripts. Just like the strings, we should be able to loop. So we create this special data type, I equals 0, and we want to loop while I is less than nums.size, increment I, and here we'll just display, right? So we'll say cout the current num at index I, new line. Let's go ahead and create a new line, another new line over here. And I'll also go ahead and do the for range loop, right? Okay, so we have the for range loop, so we can say for, let's do auto, for auto n and nums, and if we hover over n, then it knows that it's an integer, right? It's a number. And then we can say cout the current number, add a new line. And here we can say for ranged. And then we can go ahead and execute this one. So we loop with the index 10.320, and then we loop with the for range 10.320. So although it works loop-wise like the string does, let's make sure we understand that we are iterating the data type, right? So integer. If we wanted to show that, well, can we let's maybe do doubles, right? 10.5, 3.3, 0.2, 20.5. Make sure that's going to work. That should work, and then we can say run in terminal. Right, so notice, like, all the code stayed the same. I just changed the data type here, and I purposely changed the values, right, to show that, yes, we can also work with doubles. Well, they're trying to manage memory efficiently. So if each time we add one element to the list and we always get a new memory, then we're not using memory efficiently, right? So what they do is like, well, you had 3, so let me double your memory just to make sure that if you keep on adding, at least you have a little buffer. So that's why they do that, right? Because if we only increased it by 1, we would still have to get a new chunk of memory. And then if we add another one, then we have to get another chunk of memory and delete the old memory. So it's kind of like we're not using memory wisely. Okay, so can we add 3 equals greater 9? Okay, what? Understanding the last question. Okay. Well, that's mostly that's how most implementations are for the vector, right? So it all depends. Like this compiler is GCC compiler, right? It's an open source, so the open source community, that's how they implemented it. And I think the Clang compiler, it's also like that. So most implementations double the memory. No, you cannot mix data types, right? So I can't, because I'm saying like I want to work with doubles, so I can't mix. All of them have to be doubles, or if it's a list of integers, all of them have to be integers, and if it's strings, all of them have to be strings. Yeah. So if I want to do strings, then and then I have to make sure I change this, right? So okay, and I have to tell it what string is. Joe, Mary, Bob, John, I guess. We have to tell it what a string is, so include string using string. Oops. And everything should still works. I mean, I know the variable name is nums, but I don't want to go and change all of those. So I'll say running terminal. And notice the code still works, right? We just have to make sure that we keep our promise. I promise you I'm going to create a list of strings, so then we provide strings. If we say integers, then we provide integers. How can we work with different data types? We have to create our own user-defined type, right? And then we can store different data types in our user-defined type, and that's how we can get around working with that. That's all I have for today, but there's a class assignment, so don't log off and yet, right? So it should be available in a minute or so. Let me